All right. What up, mathletes? Whoop, whoop. Man, I spaced out there again. I'm getting tired today, but it's all right. I'm in a hot room. I'm cozy. We're winding down for the year. Each term of an arithmetic sequence can be expressed in terms of the first term, a sub 1. That's called a sub 1. It just means the first term. And the common difference, d. So I'm going to move through these slides, and I'm going to help you create a general rule for the sequence 22, 17, 12, 7, and 2. Watch this. It's actually pretty cool. So we're going to talk about the very first term of the sequence. All it is the first term of the sequence. It's the number 22. Okay? The second term, we take the first term, and we're going to add the common difference. What's the common difference? It's minus 5. We're going to add one of those. So the second term of the sequence, and that gets me to 17, by the way. Second term in the sequence, what happens? Or I mean the third, I take the first one, and I'm going to add in it 2 times the common difference. Because, right, we're going to apply the common difference twice. So it's going to be 2 times negative 5, which is negative 10. 22 minus 10 is 12. Fourth term, similar. We're going to take the first term, and we're going to add 3 times the common difference. Because we're 3 down the line now. We've done this once, twice, 3 times. We're taking that difference and applying it to get to this term, and we have 3 times negative 5 is negative 15, plus 22 is 7. And the last one we're going to show is the fifth term, and what is it? It's the first term plus 4 times the common difference. So 22 plus 4 times negative 5, which is negative 20, and 22 plus negative 20 is 2. And you can imagine this could get negative very quickly. And we go down to the nth term, which is just basically out to infinity. It's going to be the first term plus, now let me explain this n minus 1. Do you notice that when we're on the second term, we're only adding 1 common difference? We're on the third term, so term 3, we're adding 2 common differences. When we're on the fourth term, we're adding 3 common differences. And when we're on the fifth term, we're adding 4 common differences. You notice every time. So again, let me do that. When we're on the second term, we're adding 1 common difference. When we're on the third term, we're adding 2 common differences. Notice I put down 1 finger each time. When we're on the fourth term, I'm adding 3 times the common difference. When we're on the fifth term, I'm adding 4 times the common differences. Each time, we're adding 1 less common difference than the term we're on. So if I'm on the fifth term, I'm only adding 4. If I'm on the 8th term, I'd only be adding 7 times the common difference. If I was on the 50th term, I'd be adding 49 times the common difference. So when we're at the nth term, we're adding n minus 1, so 1 less than n times the common difference. Okay? And what that shows out to is this. This is where that's important. That becomes 22 plus our n minus 1 and times our common difference of negative 5. Now, I'm going to distribute this negative 5. And I get 22 plus negative 5n. What's negative 5 times negative 1? Plus 5. Here's where it gets cool. So I'm going to put the negative 5 in first. And then I can combine my like terms of 22 and 5. And I get, and it's a plus 5, so what do I get? Plus 32. That is how we come up with an equation for a linear or an arithmetic sequence. All right, write that down. We're going to keep rolling. So we're going to put this into practice now. I just kind of showed you what you did. Now we're going to do this together. I got a sneak peek at some of them answers, but let's look at 13, 8, 3, 2. What are we doing each time? 13 minus 8 is 5. 8 minus 3 is 5. 3 minus negative 2 is 5 again. So what's the common difference? It's going to be 5. Oh, I'm sorry. It's minus 5. I tried to put my minus in there. Look at that. There we go. All right. That's like what I do wrong. Okay. Now let's go to the next step of creating a function. We know our a sub n is equal to, so our last term is equal to our first term plus n minus 1 times d. This is just a general formula for arithmetic sequences. So I'm going to plug in my first term, which is 13. That's the first thing we need to do, and we plugged in our common difference of negative 5. Okay, that's all we're doing. Let's check it. Boosh. Let's go to our next step. And now I'm going to distribute it. So negative 5 times n is negative 5n. Negative 5 times negative 1 is plus 5. And then last but certainly not least, we're going to rearrange this. We're going to put the negative 5 in first, and then 13 plus 5 is 18. Awesome. You see right there, negative 5n plus 18. Good job. You know I got to reset this. We're going to try this now on our own. Let's see what happens. So here's our sequence, negative 4, negative 1, 2, and 5. Okay. So the first thing, we need to write an equation. So we know, again, our a sub n is equal to our first term. So our last term is equal to our first term plus n minus 1 times our common difference. Well, let's figure this out. This is going to equal, what's the first term in our sequence? It's negative 4. And negative 4 minus negative 1, right? Oh, excuse me. Negative 1 minus negative 4 is going to end up being, what are we moving by? We're doing plus 3 each time. You can see that right there. Plus 3, plus 3. So we're going to do, all right, the first term plus our n minus 1 times, what's our common difference? 3. And then let's go ahead and distribute this out. So I'm going to have negative 4 plus 3 times n minus 3. So again, I'm going to put this in front. We're going to have 3n. And then I'm going to combine negative 3 and negative 4. What am I going to get? Negative 7. So this is 3n minus 7 is the sequence. Awesome. And we can try it for the third term in the sequence. We should get 2. 3 times 2 is 6. 1, 2, 3. Well, I was saying the third term, but I was multiplying by 2, so it'd be 3 times 3 is 9. 9 minus 7 is what? It's 2, which gets us that. For our fourth term, we would have 3 times 4 is 12. 12 minus 7 is 5. Look at that. It works amazingly. And if I wanted to find, say, the 16th term, the reason why we like to find equations is, what if I say I want to find the 50th term? I certainly don't want to carry this out 50 times. I would just simply say, all right, that's 3 times 50. Minus 7, which is going to be 150 minus 7, or 143. Much easier than writing out negative 4, negative 1, 2, 5, 8, 11, 14. You know what I mean? Going out like that. So there we go. Pause if you need to. We're rolling. Oh, yeah. I can feel myself. Tiredness coming in. Watch this animation to see how much money Laniqua saved for a trip to Spain.
Laniqua opened a savings account to save for a trip to Spain. With the cost of plane tickets, food, hotel, and other expenses, she needs to save $1,600. She opened the account with $525. Every month, she adds the same amount to her account using the money she earns at her after-school job. From her bank statement, Laniqua can write a function that represents the balance of her savings account.
Okay, so we see her balance. We see it started out. Let's see, 2, 3. Okay, so we're starting balance of 525. So that's going to be our initial amount, right? Then it went up to 580. So that was a jump of what? Looks like $55. And if we apply that, it should be at 635, yeah, plus 55. And then plus 55 is going to go to 690, okay? So let's try this out. We know our a sub n, put our formula in there, equals our first term, which is 525, plus, we're going to put in our n minus 1 times 55. That's it. And then let's distribute. When I distribute, I get 525 plus 55n minus 55. And what's 525 minus 55? Or 70. So when I write this out, I'm going to get 55n plus 470. And we can try that out. If I want the 1, 2, 3, 4, I can say, all right, what's the fourth term? So I'm going to have 55 times 4. Whoa, that just happened here. So I'm going to have 50.
Maniqua opened.
Stop it. Get back here. 55 times 4. Don't make fun of my 4. Plus 470. And let's see, 4 times 55 is going to be 220. 220 plus 470. Guess what that is? That is indeed $690, which we have right here. Ooh, class about to start. So let's look down here. We know it's 55n plus 470. What are the questions we're going to ask? Oh, we already created the function. Now it wants us to graph the function and determine its domain. Well, we know that at n equals 0, it's 470, right? Because 55 times 0. And so when we graph it, we're going to be at 470, which is about right there. And the first one was 525. Filled it in while it was paused. Let's see, let's go to 1. I can't really see all this. Is that all it is? Okay. At 1, we're at 525. Why wouldn't it let me stick a thing on there? I don't know, this isn't working, but you get the idea. It'd be a linear graph going all the way up. I don't know what the heck. I have to use my own drawing. So it would be from about 470, boom, right there, to 525, right there, up to 580, right there, up to 635, right there. Do you see how this is going to be linear? Right? It's just how we're rolling all the way up to 800. Boom. Right there. Boom. And it'd be a nice straight line through there. Perfect. Awesome. All right. Well, that's it. Boom. You guys have an amazing day. Get them sequences going. Peace out.